Alright, so in this problem we're looking at single replacement or single displacement. They're both synonymous. And we are first being given only the reactants to see if even a reaction is possible. And the reason why is because in a single displacement or single replacement, I say displacement reaction, you're going to have an element, so we're going to say an element plus a compound. Okay. And based off of the reactivity of this element and whatever it is in the compound, there will be a different one and you'll see this example here. Like if it's a metal, you would look at the metal in the compound or non-metal and vice versa. But depending on the reactivity of, say, your metal in this case, and the metal in the compound, if this guy's reactive enough, he can actually kick the other metal out to form a new compound. So we'll say this element A, where now you have a new compound that contains element A plus the element that got kicked out. Okay, so we'll say like element B. We'll say that this has element B in it. Okay, and so it's really a replacement, or he goes and replaces somebody else. You can think about it. Oops, that was a delta sign. Physics. You've got A plus Bx, and if A is strong enough, it can kick B out. All right, and so if it kicks B out, now you got B by itself and A in the compound. Okay, so A replaces B in this case. So let's look at our reactants. We're going to practice having to write them out first and then even predict whether the reaction would occur or not. Okay, so we're going to have solid potassium and aqueous zinc 2 chloride reacting. Okay, potassium is an element and it is not one of our diatomic, so we just write K for potassium, and it's a solid. And we're going to put it with zinc 2 chloride. And this is a compound. It is an ionic compound, so you have to swap and drop the charges. So zinc 2 tells me that that's Zn with a 2 plus charge. And then we've got chloride, which is Cl and a 1 minus charge because it's in group 17. If you swap and drop, you get ZnCl2. I'm going to write this down here where it's bigger. So we're going to have solid potassium and zinc 2 chloride in an aqueous solution. We want to see if a reaction will take place. Alright, so in order to figure this out, I got to say, okay, well that's a metal, so I need to find the metal in this compound. We know with all compounds that contain metals, the metal is going to be first. So what I need to do now is look at potassium and zinc. So we're going to look for potassium versus zinc on our activity series. If you look at the periodic table I printed off, on the back side you wrote down your activity series for the metals. Okay. So you want to find potassium, which is right here, and you want to find zinc, which is down here. So we've got potassium and zinc. Okay. With the activity series, they decrease in reactivity going down. So anything high up on the list will replace anything below it. So potassium is stronger than zinc, or more reactive, we'll say. So since potassium is more reactive than zinc, potassium is strong enough to kick zinc out. So zinc metal will be by itself. And so the zinc by itself is going to be a solid. And now we're going to have potassium and chlorine. So that's going to be potassium and chlorine. It should be an ionic compound because we've got a metal and a non-metal, so we have to swap and drop the charges again. Potassium is a 1 plus because it's in group 1. Chlorine is a 1 minus. So if you swap and drop, you get KCl. So that will be our other product, and that's going to remain aqueous. So we're going to have one solid that kicks something out of an aqueous compound, and then we will end up with a new solid in a separate aqueous solution, or different. Okay, we need to balance this now. We see we've got 1 potassium, 1 potassium, 1 zinc, 1 zinc, 2 chlorines, and only 1 chlorine. So if we do that, now we've got 2 potassiums. I've got to put a 2 here to balance that out. So this would be our balanced chemical equation. I'm going to do that so that way those Z's don't look like 2's. Okay, and that'll be it.